Okay, welcome back. So, we're going to continue on in section 3, chapter 11. Our target for today is I can use a standard normal table to find various probabilities, otherwise known as z-scores today. Okay, standard normal distribution, basically scores are converted to be even more normalized, to be more standardized, so that you can take a data set that could have a mean of 500 and another data set that has a mean of 50. If you can convert both of those data values to z-scores, you can more directly compare those data values. So basically everything is converted to scores where the x-bar or the average is 0 and the standard deviation is 1. You see this a lot in research. They convert data to z-scores because then you can compare more easily between different types of research what the probabilities are for a given data set. You'll see the example, I'm not going to actually do it on this slide, but the probability that z is less than or equal to 2, that's much like the same thing as the probability that x is less than or equal to x bar plus 2 standard deviations. It's just another way to think about it. Okay, it's the same. It's the same concept. Okay. In your book on page 759 is the standard normal table. Part of it, the hardest thing is just learning how to read it, and once you know how to read it, the rest is pretty straightforward, pretty easy, just picking numbers off the table. Basically, the probability it gives you in a z-score is the probability that something is less than a given value. So it's not the probability of exactly, in this case, negative 1.6, it's the probability that it's less than negative 1.6. That's what's in the table. So negative 1.6, negative 1, that's this row. Okay, 0.6 is this row. Where they come together, that's your probability. So negative 1.6, the probability of that is 0.0548, or 5.48%. Okay? So that's how you, and that makes sense because that's almost 2 standard deviations away from the mean to the left. So for less than that, negative 1.6, it's going to be just this little tail section over here. That's what we're doing. Okay? So you can see that z-scores also allow us to find values that don't fall right onto a standard deviation. So that's another advantage to z-scores as well. So let's just kind of find values between standard deviations and what their probabilities are. Okay, so let's do some more practice. Find the probability that z is less than or equal to negative 0.4. So all these are set up for negative 0.4 or less than values, negative 0.4. Well, here's 0.4, negative 0. That's the only time where you'll see negative 0 on anything, but it's negative 0 point these values. So negative 0.4, that has a probability of 0.3446, 0.3446. How about the probability that z is greater than 2.6? Well, greater than 2.6, well, this is how you can do a greater than. We know that this whole probability table, everything adds up to 1. So if we go to 2.6, that is right here, 0.995, that's less than though. So if we want to flip that around, if we know that 2.6, that'd be right here, if this is 0.9953, the whole thing is 1. So to get this little overlap part, this tiny little piece right here, we take 1 and we subtract the 0.9953, which gives us a probability of 0.0047. And if you look on your data table, 0.0047, that's the same as negative 2.6. So this really is the same thing as flipping everything, dividing everything by negative 1 in its essence. and saying the probability of z is less than or equal to negative 2.6. That's another way that you can find these kind of more quickly. So either you take the probability for the data value and subtract it from 1 for greater than, or you flip it around and say, well, it's the equivalent of less than the opposite value, if you will. Okay, so let's look at one where it's between two data sets or two data values. The probability that z is between negative 0.1 and the probability that it's between 2.6. Well, we have 2.6 right here. Let's circle that again in red. 0.1, negative 0.1, 0.1, that's 0.4602. The probability that's between those is just the difference of those numbers. So we subtract them and we get 0.5351. Okay, so I told you that they take data values or information and they change them over to z-scores. We have a formula for that. Okay, so a normal distribution has a mean of 90 and a standard deviation of 7. What is the z-score corresponding to a value of 78? Can we see where it's going on here? Corresponding. So if you want to take a data set and change them into z-scores, this is the formula that's going to do it for you. So, x minus x bar over the standard deviation. Now, think about this. Our value is 78. Our average is 90. Should our z-score be positive or negative if our value is below the mean? It should be negative. Okay, we're doing a standard deviation left of the mean. We're going towards standard deviations left of the mean. We're going to have negative z-scores. Positive z-scores are if we are above the mean. So our value is 78. Subtract 90. That's where people make their mistake, is they sometimes just go biggest minus smallest. That's not always the case. You've got to have x minus x bar. It's got to be in the correct spot. So 78 minus 90 over 12, or 7, excuse me, is negative 12 over 7, which we're going to round. It's about negative 1.71. We round that to one decimal place, always. Okay? So our z-score would be negative 1.71. Excuse me, negative 1.7. Okay, let's put this all together. Let's use a z-score, and let's use a mean and standard deviation, and try to find the probability using z-scores. So if values fall, then we're trying to find the probability of fall right on the standard deviation. That's great, and we can just use the table we learned about yesterday. Most data is not going to fall right on the standard deviation above or below. So that's why z-scores are a necessity. So first thing we're going to do is we're going to calculate the z-score. We have to find the z-score for the value or values we're looking at. So 245 minus our mean, which is 258. So we're below the mean again. And our standard deviation is 22. So that's what we're going to do to find our z-score. So that's negative 13 over 22. And that is about negative 0.59, and we will say, for our purposes, because our table goes by tenths, negative 0.6. So the probability that we are x is less than or equal to 245 is equal to find the probability that our z-score is less than or equal to negative 0.6. Negative 0.6, 0.6, that's that score right there, or 0.274. So we've taken a value that is not exactly 1 or 2 standard deviations above or below, and we've found its probability by converting it to a z-score. Okay, I believe we hit our target today. We did the standard normal table. We converted to those, found ways to kind of find those in-between probabilities where most of the data lives, between standard deviations, and hopefully you have those notes down and you can prove that you understand it tomorrow in class with your assignment. Have a good day.